So our next object that we're going to talk about is the network policy. The network policy is a Kubernetes primitive, the network policy here, and what it's designed to, to review briefly for a moment, inside Kubernetes cluster, all your pods can reach any of the other pods without natting. That's the definition of being a validated Kubernetes clusters. All pods can reach each other, all the other pods. Is that really what you want from a security standpoint? If you want to restrict a pod being able to reach another pod or a particular inflow of TCP/IP traffic into your pods, how do you restrict that? I could certainly do it externally on my edge by doing some type of firewall there, but we probably want to do something more inside my Kubernetes cluster. Kubernetes gives us a primitive to do that. It's called the network policy. The network policy is basically synonymous to saying, I want to program firewall rules. So you could see inside this manifest file, what do we've got going on here? We're going to create a network policy. We're going to call it network policy. That's the name, not real creative, but we get the point. And we're going to apply the network policy into namespace 01. We're going to apply it to what in namespace 01? The first spec up here is saying I'm applying it to pods that match this specific selector. Then I'm going to program two types of firewall rules. One of it's an ingress, so the flows into those pods. The other one is an egress, the flows coming out of those pods. And then here's the corresponding ingress and egress rules. These rules here that are defined on the ingress and egress, those rules, the NCP is going to see this when you apply this network policy. He's going to take these rules and he's going to turn these into distributed firewall rules in the NSX T platform for us. So what would it look like when I look inside NSX T? Well, I've gone to my NSX T security tab. I've come down here to my distributed firewall, and I've gone ahead, and you could do it either by category specific, or I like to just select all rules. And the applying of that one network policy actually results in two distributed firewall sections. The first section is what we refer to as a whitelist. In other words, what are we allowing through? So whatever you put in this set of firewall network policy rules, these rules will be resulted inside here. This section inside here. He's saying, what do you want to allow in? Each of these destinations and sources over here, as well as the apply to, all three of these are basically groups, and you could click on those groups, if I could spell. If you could click on those groups, they'll bring up the objects that they're being applied to. In this case, it would be a series of pods. The second firewall rule section or policy that you're going to see is the isolation one. When you apply a network policy, there's an implied deny all after you've applied it. So this is the what I want to allow through. So if I'm going to do zero trust, this should be all the rules that I want to allow through for the various flows of my traffic. The second one, you don't have to add, it's implied. This down here is going to be the deny everything else. So coming from any, going to what I've selected, drop all, and then from it, going out to any, again, drop all. So that's your implied deny all at the end of your rules. If I clicked, as I said, on one of the groups over here, you could see inside here, if we went down to my segment ports, these segment ports are corresponding to those 3 pods that I'm applying them to. And just so you're aware, the NCP is always listening. So if I would have gone in and done an increase in my replica count or a decrease in my replica count, this group would be automatically updated to reflect that change. So what have we covered in this lesson? We've talked about inside here the role of the NCP container plugin. It's running as a service or a pod on the control plane VMs, and he's going to be listening for those 4 primitive object types that I've spoke to you about. And if you create one of them, update one of them, or delete them, the NCP is going to go over to the NSX manager via the APIs to it and perform the corresponding action, creating it, updating it, or deleting it. We reviewed the topology that's being used in your supervisor cluster. That's going to involve not including just the control plane VMs, but the pods that you're deploying that are going to be running and connected to the respective namespaces. We talked about how we expose when we have multiple pods or even a single pod, but how do we gain connectivity outside of our Kubernetes cluster? We spoke to you about services, specifically the load balancer, and then we wrapped it up with taking a look at the network policies. So this was a lot to digest. And what we're going to do to help you get a little more familiar with it is we've got 3 labs that you're going to go through to explore the things we've just discussed. The first one is you're going to create a load balancer. And this will be the first time that you'll actually be able to access the pods that you deployed, your NGINX pods. So you'll go ahead and you'll apply the load balancer manifest file that we're giving to you. You're going to go ahead and see what external IP address it's listening on. You're going to open up a browser tab and you'll see the welcome page to the NGINX container app that we've deployed. Then we're going to go a little bit further. You now are able to reach the NGINX. And what we're going to do is we're going to create a network policy that's going to deny all traffic to it. Go ahead and refresh your browser, and you're going to see you can't connect to the NGINX. Then we're going to explore in lab number 12 here. You're going to go ahead and jump into the NSX T graphical user interface, and you're going to explore all of these components, and you'll actually see the firewall rules that are blocking connectivity to your NGINX application. So go ahead, have fun in the labs. Don't be afraid to look around a little bit, explore some, and then I'll see you when you come back from the lab, where we're going to talk about an option that we have with vSphere with Tanzu is we don't have to deploy it with NSXT. That could be your business decision to choose. And if that's the route you want to go, what would the deployment look like when you deploy it on a vSphere distributed switch? All righty, I'll see you soon.